Assalamualaikum everyone. Today in this video we are going to discuss the topic discrete random variable. Discrete means non-continuous. It means that our number is non-continuous. You can say with the example that it does not contain any infinite value. It means that we have some kind of integer values like 1, 2, 3, 4 and so on. But for the thing which is not discrete or continuous, we are going to have the infinite value even in between 1 and 2, which is kind of 1.001, 1.0003. So this is known as continuous value. So this is not discrete. But in this chapter or in this topic, we are going to study non-continuous value, which can also be said that integer values. Okay. Now, in this topic, the first subtopic which has been discussed is of probability mass function, which is also known as PMF, probability mass function. But what is this and how we will understand this thing? We need to either show with any formula or we need to draw a table for this. So, for your assistance, I'm going to draw the table over here, like such as I am writing the question that you are giving the tetrahedral die, you are given a tetrahedral die, it means that a die which has 4 sides. Okay, so you are given a tetrahedral die which consists of a number listing 1, 2, 2, 4. Okay, so these are the values of our possible outcomes, but we need to know that we can only show our probability mass function by the help of two things. Firstly, with formula, and also with the table. So I'm going to show with both the things. Let's take these values as x. So our random variable is considered as x, and the corresponding probability for this x is written below it. Okay, starting with the values that you have given, like the initial values are 1, 2, okay, I have to erase this comma, 1, 2, and the last possible option is 4. Okay, now we are closing this table like this. I'm going to show you that the possibility probability which can be contained of this, which it consists. Let's suppose if we are getting 1, so we are getting 1 from the 4 possible outcomes, so it would be 1 upon 4, or you can also say like 0.25. Okay, so this probability is basically 0.25. This probability is basically 0.5 because you have two 2's and you don't know which two you are going to pick, and you have only 1 4, so it is also 0.25 probability. Now with the formula, you must know that the probability mass function must have the values of probability which is equal to 1. So the sum of these values of probability must be equal to 1, and you can see from this that you are adding these probabilities and you are going to say that the sum is of these probabilities equal to 1. Now, for in this, they are going to find the mean. Mean can also be say like this, mu. But in this chapter, we are going to learn some different kind of names. So mean can also be say like this, or you can also write mean as an expected value. This is known as expected value. This is also mean. This is also mean. These all are the symbols of the mean. This is known as expected value or mathematical expected. So there are numerous kind of names which is given to this thing, but you should know that this is mean. But for this probability mass function, you are going to calculate your mean by multiplying your x value with the corresponding probability and sum it. So you will see that you will get the answer by this. You are going to multiply your particular x value. I'm going to change my pen color. So you are going to multiply the value of x with its corresponding probability, and you will see that you will get the answer after summing this sum up. Okay, from this you can get the answer of your probability. So this is basically not probability, this is basically mean. Okay, which can also be say like this, not like this, like this. Now we are going to study some more further things in this chapter. First of all, we have understood what is probability mass function and how we can do our calculations from probability mass function of our expected value mean. Expected value or mean, because these are different names given to this specific thing. Now we are going to calculate the variance of this probability mass function. In order to calculate the variance, you must know that the formula for calculating the variance is like this. You have to multiply your value, you have to square your random x value and multiply with its corresponding probability, and finally subtract with the square of mean. So what is your mean? Your expected value. It is your choice in which order you are going to write this particular thing. So this is known as your variance, which is basically the square of standard deviation. You must know that the standard deviation square equals to variance. And in order to write the formula, you will see that the standard deviation is like this, and if you will square this, it will ultimately equal to variance of x. Okay, so these are the formula which is written. So this is the basically the formula that we are going to square the x value and multiply with its corresponding probability and subtract with the expected value square. Okay, now in this question you are going to see this. At firstly, you need to square the value of 1. 1 square is 1 and multiply with its corresponding probability, which is 0.25. Then 2 square to 4 and multiply with its corresponding probability, it would be 0.5, 4 into 0.5, 1. So in this order, we are going to write all these things. So I'm going to write this and you will see. Now I'm going to square every probability of x, every value of x, and multiply with its corresponding probability, which is 0.25. But you should know that this is basically the summation. I have forgot to write the summation sign. So this is basically the summation of these values. Okay, so you are going to multiply your x values. X value with itself means x square with its corresponding probability. Okay, now you are going to sum this. 2 square 2 is 4 into 0.5. 4 squares is basically 16 into 0.25, and subtract with the value of mean. Okay, first of all check this, you will get 0.25. In addition with 4 into 0.5, it will be equal to 1. 16 into 0.25, it will be equal to 4. So this is basically equals to 5.25. But what is your mean? Your mean was, we haven't calculated the mean. The mean would be multiply with the x values with its corresponding value, with its corresponding probability, 0.25, 1, 1. Okay, so it would be 2.25. I cannot solve. Wait for a while. Okay, so basically 2.25 square, 2.25 square, 2.25 square. After subtracting the 5.25 with the square of 2.25, you will ultimately get the variance of the specific value of x. Okay, so these are the things which we have learned in the probability mass function. The way of calculating the mean, which is also known as expected value, and also the way of calculating variance. Okay, now we are going to move towards the probability distribution table, or you can say the probability distribution. In probability distribution, you are going to see, or you are going to witness the way of writing our probability is little bit different, like this. And in this, we have to show with an inequality sign, such as like this. Probability of x is less than equal to with x, and this is basically equal to the sum of initial value of x always 0, and then multiply, or you can say that we're going to sum the value of probability only. So this is basically known as probability cumulative density function. Okay, probability distribution, or you can say that cumulative density. This is basically cumulative density function. Cumulative density function. Okay, now we are going to solve some of the questions of expected value, which is also known as mathematical expectation, and also some of the questions of variance. But before this, we are going to learn some properties of expected value and variance. The properties of expected value are like this. You need to understand the properties of mathematical expectation or the expected value. The first property is that if you are going to witness any constant in the place of expectation, you will see that you will get the same answer. Okay, expectation of C equal to C. So this is basically the property number one. What about property number two? It would be like this, that if you got the function y equals to ax, and you have been given the question, find out the expectation of y. So you know that the y is can be substituted at the place of ax. So you are going to substitute ax at the place of y, and you will witness that x is the variable, but a is the constant value, and this constant value can be taken outside the expected value. So it means that writing this can be written in this form: a multiplying with expected value of x. So these all are the probabilities, or sorry, these all are the properties of the expectation which you need to learn. Also, that ax plus b, so then it will move towards the same thing. A would be outside our bracket, multiply with its expected value, and in addition with b. And you know that the whenever b comes inside the here, you will see that a into expected value of x, although b is also constant, so this would become b. Why? Because of this first property. So these are some kind of different properties we are going to see in this question. Okay, now further moving to more things, you need to know that if you got the negative value of any constant, you will get the negative value. If you will get the positive value, you will get the positive value, because in the mean, which is also known as expectation, which we are studying right now, there will be a no change of sign. Let's suppose if this would be minus c, it would be minus c, our answer. Okay, we are going to study, or you are going to solve some questions of this expected value. But before this, we are going to also learn or write some properties of variance. Okay, but you need to know that variance is basically the square of everything, or you can say that the variance, which is also known as the square of standard deviation. So these have properties little bit different with expected value. Okay, properties of variance. Okay, now we are going to study some of the properties of variance, like, okay, you have to also know that the variance can also be written in this form, basically the expected value, sorry, this is basically the summation multiplying with x minus mean. Moment about origin or moment about mean is the first mean. Okay, so this is mean, and you are going to square this thing, not the whole thing, but only this bracket. So this is another form of variance. Anyways, we are going to move towards the properties of variance. The first property is that if you will witness any constant value in variance, you will see that you will get the answer 0. Okay, we will prove these properties, but first we are going to write all the properties in one go. If your y function is basically equal to bx, and you are going to find the variance of y, it means we are going to find the variance of bx. And you know that in the question it is written that the b is basically the constant, so b will be coming out of the bracket, out of the variance formula, but it will be making square, it would be square, b square variance of x. Okay, now number third, if you are going to witness any constant in the denominator, let's suppose b over x, sorry, x over b, so you are going to see that b will come outside the bracket after squaring. Okay, so it would be 1 over b square multiply with variance of x. These all are the properties which we are going to solve, or we are going to learn, and after this we will try to solve some of the questions of these things. Also, if you are going to have any addition of the two functions, so you will see that you will write in this form variance of x in addition with variance of y. Okay, and if you are going to witness any of the thing x minus y, you will see that you will also add this thing variance of x plus variance of minus y. But you should know that the minus y means that minus 1 is multiplying with y. So if you will make the square, if you will make the square of this minus 1, so it will become 1. So in this question we will also receive same thing, variance of x plus variance of y. Okay, this is the same continuation of the property. Property number 5. I think we don't have any much properties beyond this. So we are going to we can be solving some of the questions, but before this we should also know that in probability mass function, which we have discussed early on, in which we have the two values, we have the table divided in the two rows, x and then probability of its corresponding value of x. So the probability of these corresponding x must be always equal to 1. So this is very much important principle which we need to follow in order to solve the questions of probability mass function. Okay, now before moving toward the calculations or the numericals of these properties, we are going to also see some of the more things which have been discussed, like the special case of random variable, or you can say that basically we are going to discuss the binomial distribution. In binomial distribution, you must know that the way of writing is little bit different in binomial distribution. But before moving towards the binomial distribution, we are going to see that the value of basically the value z is basically the standard value. Z is the standard value of anything. If you are receiving any standard value in this, you will ultimately see that the mean would be equal to 0. Sorry, mean would be equal to 1. No, it would be equal to 0. And the variance or standard deviation, it would be equal to 1. So you can write that if it is normally distributed. We are going to discuss normal distribution later on, but first of all we are discussing normal distribution. The way of writing normal distribution is little bit different. Like this, if you will see that you are normally distributed, you will receive that you will have mean over here and variance over here. So you will see that the z like comma 1. So it will always show that you are at standard position. Standard position. If you are receiving, because this is the place of mean and this is the place of variance. Okay. This is the place of mean and this is the place of variance. And if you are receiving 0 over here and 1 over here, it means you are at z value. You are at standard value. Okay, but if you are having the x value which is not standard, you will see that you have to standardize this. To make standardize the value, you need to make this value, you need to subtract the mean from this and divide it by the standard deviation. Then you will get the same ultimate z value which is going to be standardized by this formula if you are receiving any x value. Because in this x value, the mean is not equal to 0 and the variance is also not equal to 1 and the standard deviation is also not equal to 1. So these things will ultimately show you that you are not at standard, not standard. To make it standard, you need to use this formula to standardize your value. Okay, we will discuss binomial distribution later on, but for now, we have discussed some of the things which I have covered. We must revise these things and then we are going to discuss binomial distribution later on. For now, Allah Hafiz.